Hello Year 3 and welcome to today's maths lesson. We're going to be carrying on with equivalent fractions. So I've got your do now here. It's going to be reviewing our comparison of fractions with the same denominator. So for each pair of fractions you're going to need to decide whether it is greater than, equal to or less than. So you're going to look at the two pairs of fraction and is the first fraction greater than, equal to or less than. So let's look at this first one as an example. 3/15 and 9/15. Remember, we're only looking at the numerator because the denominator is the same. Is 3/15 smaller, larger or the same as 9/15? I think it's smaller because 3 is a smaller number than 9. So I'm just going to draw my little less than sign there. Okay. Pause now to complete the do now. Okay, brilliant. Let's have a look at these answers, see how we did. So the first one obviously is less than. The next two are equal to because they're the same fraction. A third is the same as a third and the half is the same as a half. The next one, 2/4, is greater than 1/4. Number 5, 2/6 is smaller than 3/6. Number 6, 5/25 is a smaller fraction than 9/25 because there the numerator is a higher number. 12/24 is bigger than 3/24. Number 8, 1/10 is smaller than 7/10. And number 9, 10/16 is larger than 2/16. So I hope we all understood that well. Okay, so today we're carrying on with equivalent fractions. So our star words for today: my turn, your turn. Fraction, equivalent, equal to, whole and part. Excellent. So we made a really good start on Friday with equivalent fractions. So we're going to be carrying on and looking at some different fractions which are equal to each other. What do you notice about this wall? How many blue bars are equal to one green bar? How many green bars are equal to one red bar? Have a think. Maybe pause the video and have a think. Okay, how many blue bars are equal to one green bar? So we can see here we've got our blue bars, then our green bars, and our red bar. So how many blue bars are there for every green bar? There are 1, 2 blue bars for every green bar. So I'm just going to write. How many green bars are equal to one red bar? There are 1, 2, 3 green bars equal to every red bar. Interesting. We're going to take a look on the visualizer and see a little bit more about this. So let's imagine our red bar is the whole. I'm going to write it as 1. How many parts is my green bar divided into? 1, 2, 3 parts. If it's divided into 3 equal parts, I know that my denominator is going to be 3. And each one of these parts is a third. 1/3, 2/3, 3/3. 1, 2, 3. 3/3 make up a whole. 3/3 make up a whole. Now let's look at the lower block. How many blue blocks do we have? 1, 2, 3, 4, 5, 6. So my whole, which is my red bar, is divided into 6 equal pieces. This means my denominator is going to be 6. 1/6, 1/6. Now let's have a look. 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So we can say 1 whole, 3/3, and 6/6. One whole is the same as 3/3. Let's put my equal sign so we know, and which is the same as 6/6. If I have if I have a whole divided into 3 parts, I need 3 parts to make my whole. If I have a whole divided into 6 parts, I need 6 parts to make my whole. Straightforward. Let's have a look at another example. So we've looked at thirds and sixths. Let's look at another example. What do you notice about this wall? How many yellow bars are equal to 1 pink bar? How many pink bars are equal to the red bar? Want you to have a think about this? Pause your video. Okay. How many yellow bars are equal to 1 pink bar? So here are my yellow bars, here's my pink bar. So for every pink bar, there are 1, 2 yellow bars. Now, let's go up a level. How many pink bars are equal to the red bar? 1, 2, 3, 4, 5. So for my whole, which is my red bar, I need 5 pink bars. Let's take a look at it just like we did with our previous example. Again, I'm going to call our red bar, our whole, I'm going to call it 1. The number 1. How many pink bars do we have? How many pink? My whole 1 is being divided into equal parts. How many parts? 1, 2, 3, 4, 5. It's been divided into 5 equal parts. I know that when something is divided into 5 equal parts, out of a whole, my denominator is going to be 5. So each of these parts is equivalent. It means 1/5. 1, 2, 3, 4, 5. 1/5, 2/5, 3/5, 4/5, 5/5. 5/5 equal a whole. Remember, whole in this sense, it's not going down the rabbit hole, it's got a W. You can do some English and some maths as well. 1 whole is equal to 5/5, which we would write like that. We've got another layer, our yellow bars. This is my whole. I've split it into how many equal pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. So instead of having my denominator as 5, it's 5, because that's 5 equal pieces. This is into 10 equal pieces. So my denominator is going to be 10. 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10, 1/10. My whole is divided into 10 equal pieces. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. 10 tenths. 10 parts of 10. That is complicated as that is. So let's recap quickly. My whole here has been divided into 3 equal parts. To make my whole, again, I need to put all my 3 equal parts together. My whole here can also be divided into 6 equal parts. To get my whole, I can also need to put my 6 equal parts together. 1 whole equals 3/3 and 6/6. My whole here, first of all, split into 5 equal parts. To make my whole again, I need my 5 equal parts put together again, which is 5/5. My whole is then taken into and broken into 10 equal parts. Each one is valued at a tenth. Each one is worth a tenth. I want my whole back together again. I need to put all my 10 equal parts together, which is 10 tenths. So here we've got a fraction wall which shows kind of a lot of the different relationships that we've been looking at. It shows lots of the different relationships that we've been looking at over the last couple of days. As you can see here, it includes at the top here are the halves, and you can see here the number of the denominator is increasing. It's going up as you go down. But look at the size of these parts. These are the parts. Remember, the denominator goes up, the size of the part gets smaller. Just think how you're sharing it with, you're sharing something with more people. So, looking at this table to help us, and thinking back to what we discussed. How many sixths are equivalent to 1/3? How many sixths are equivalent to 1/3? How many sixths are equivalent to 2/3? Pause the video and have a think about this. Okay, there's a couple of ways you can try and work this out. One way is you can actually use, if you have been able to print out your fraction wall, you can actually use a ruler. I'll quickly show you how that works, but it's not the only way. So 1/3, I would put my line on the barrier here where it says 1/3, and I would move my finger down, and I can see here I've got 1/6. I've got 2 6 are equal to 1/3. 1, 2, 1/3. And you can actually see we looked at that. We were looking at that. We were looking at thirds in our sixth relationship earlier. So you can see that 1/3 here is the same. 2 blue blocks is the same as a green block, and each blue block is worth 1/6. And you can actually even see that on this one here. 1 green block here is worth 2 of these blue blocks. So 1/3 is the same as 2 sixths. How many sixths are equivalent to 2/3? Well, if you think about it, we know what 1/3 is in sixths. I wonder if we can work out what 2/3 are in sixths. Let's have a first look on our fraction wall. I'm going to show you here. So I have my 2/3 here. I'm going to draw a line down, or I can just look and I can see my 2 green blocks here, 1, 2, are equal to 1, 2, 3, 4 sixths. 2/3 are equal to 4/6. Have you spotted a relationship between some of these numbers yet? Or could you work that out using the pattern? As I said, if you've worked it out, write it down on your independent task and upload it to Seesaw. Let's have a look at another example, because this is going to be the base of your independent task. How many tenths are equivalent to 1/5? How many tenths are equivalent to 1/5? How many tenths are equivalent to 2/5? How many tenths are equivalent to 2/5? Pause the video now, have a think, and we'll come back and discuss. Okay, so we've got our fraction wall that can help us, but we can also, let's have a look at the first wall one of the first walls we looked at. How many tenths is equal to 1/5? That is asking us how many yellow blocks are equal to one pink block. How many tenths are equal to 1/5? You can see here, 1, 2. They fit together nicely. Having a look on our larger fraction wall, it's exactly the same idea. Put our ruler down, it's none of the way, and we can shoot down we're going to shoot down to, it's 2/10. So 1/5 equals 2/10. Now let's look at the other question. Now that you know how many tenths are equal to fifths and how many fifths are equal to tenths, I wonder if you can work out how many tenths are equal to 2/5. Now let's have another look at our initial model. So I want to know how many yellow blocks are equal to 2 pink blocks. So I've got two pink blocks here. So I know that 1/5 is the same as 2/10. I know I've added one more pink block. So therefore, I need to add on another 2 yellow blocks. As you can see here, 2/5 are equal to 4 yellow blocks, which are 4/10. 1, 2, 3, 4. And you can see it exactly the same on our fraction wall. So let me just get here. So here we've got our fifths and our tenths. So how many tenths are equivalent to 2/5? It was actually the other way around. So we are going to be finding here our 2/5. 1, 2, that's 2/5. So let's go down with our highlighter. And you can see the number of tenths it is 1, 2, 3, 4, as we saw just there. 2/5 is equal to 4/10. Now, are we ready to see a bit of a sneaky pattern? I think we are ready to see a sneaky pattern. 1/5 equals 2/10. 2/5 equals 4/10. 1/3 equals 2/6. 2/3 equals 4/6. Can you spot anything that happens to these numbers? Can you spot anything that happens? Actually, let's just look at this one first of all. Shows it a bit clearer this way. Obviously, we will always check our knowledge on our fraction wall. What do you need to do to 1 to get 2? What do you need to do to 5 to get 10? What do you need to do to 1 to get 2? What do you need to do to 3 to get 6? What do you need to do to get 4? What do you need to do to get 5 to get 10? What do you need to do to 3 to get 6? What do you need to do to 2 to get 4? Answers on Seesaw, please. And then I will confirm whether you've got the sneaky trick right at the start of the next lesson. Okay, so it's now time for your independent task. Very similar to what we did on Friday, but you're going to be looking at thirds and sixths and fifths and tenths. So that is your independent task. That is a challenge as usual. Please do not forget to go on Times Table Rockstars and also complete your daily arithmetic. There's also now the fractions games, which I have saved as a to-do on Purple Mash. There's a fraction wall game and also a Fractorionio. I think that's what it's called, Fractorionio pizzeria game. I won't pronounce that again. Have a great day and looking forward to seeing your work on Seesaw. Happy maths time.